Okay, brand new material every day for this unit. If you miss this unit, again, it's brand new material. You'll have tough time being able to figure it out unless you at least go and watch video. You for sure have this test and the final exam. You might have this test and another test before the final exam. We'll see what we can fit in. And in case you didn't know this, I haven't typed it in yet, but because you guys all did such excellent work in your preparation for the ACT, I'm giving you guys a free 25 out of 25 test in the gradebook. Okay, so that will help cushion. No, be careful, okay? It's not worth the same as a normal test. It'll be worth a quarter of the normal test. So it doesn't simply average, but it will help your grade in a little way. As I told you, furthermore, obviously I will add a homework grade to that as well. Okay? So, second note to make as we move forward, you will not receive any more notes from me for the test. But you may use a sheet of notes, front and back. They may not have examples on them, but they should have important things from our lessons. So I will try to comment, and you might want to circle or highlight or make a star or a smiley face. Is it called? Okay. And so we start here. We have a real axis, imaginary axis, the complex plane. We are talking about trigonometric form of complex numbers and de Moivre's theorem. This will take us 3 days to get through this lesson, but this is a shorter unit altogether. You have a lesson today and tomorrow. On Friday, you will not have a lesson. You have a work day. Okay. So here's what we have. If I give you this number, and I ask you to, yes. Oh, whoops, sorry. And if I ask you to plot 2/3 on the number line, would you know how to do that? Would you be able to plot the number 2/3 on that number line? Yes, and so you walk up and you find a number between 0 and 1, and you plot that, and you're very confident. Mr. Gens gives you a smiley face. You're like, great, that's where that goes. But what if I do this? What if I say, where does the number -1 plus 3i, where does that go on the number line? And the fact is that does not go on this number line because this has a title. It is a real number line. And so what we need is we need something else. We need a complex plane. And so we have a real axis and we have an imaginary axis, and we will use that now to plot points. So as we speak of complex numbers, we have z sub 1 is equal to 2 plus 4i. And z sub 1, I will write the real axis here. I'll write the imaginary axis here. And when we go to graph complex numbers, a complex number is in the form of a plus bi. It goes a units on the real axis and b units on the imaginary axis. So what is the a value for z sub 1? 2. So I go over 2 units. What is the b value? 4. Note that the b value is not 4i, it is just 4. So then I go up 4 units. And the way that I show this is I plot a point there, and then I draw a segment attaching it to the origin. And that would be the graph, or the plotting of the point, 2 plus 4i. So we do the next one together. Z sub 2 is equal to -1 minus 5i. Which quadrant will this put me in? Third quadrant, because you have a negative and a negative. And so we'll go back 1 and down 5, and again, I will draw my segment. There we go. Now, let's look at some other options. It says to graph z sub 1 plus z sub 2. Well, I know z sub 1 is 2 plus 4i. I know z sub 2 is -1 minus 5i. So how do you think I add those together? Combine the imaginary parts and the real parts. What do the real parts give me? 1, and the 4i and the -5i make? -i. Which quadrant will that be in? 4. So over 1 and down 1. So there we have it. Mixing it up. Free country. Do what I want. This should not say I, but it should rather say 1. Now I want to graph negative z sub 1. If z sub 1 is 2 plus 4i, what do you think negative z sub 1 is? Exactly. So if we graph that, which quadrant will that be in? It'll be in the third quadrant. If you notice, it's in the exact opposite direction as the original one. Furthermore, it is the exact same length. Notice that? What do you think we do to compute 1/2 z sub 1? Divide by 2 or multiply by 1/2, and we get 1 plus 2i. How do you think the graph of that complex number will compare to its original? It is exactly half of it. So one of the things you'll be asked to do on your test is to plot a complex number. Do you think you can do so? Very good. But it is new material. So if you miss today, then it'll be hard for you to necessarily know what to do until you either got help from me or I'll watch a video. Definition now of a modulus. Modulus is the absolute value of a complex number. Let's think in depth here a little bit. If I asked you the absolute value of negative 5, you would say, why? Because negative 5 is how many units from 0? 5 units from 0. So we define absolute value by how far something is from 0 on the number line, right? We'll look back at one of our original problems. Look at z sub 1. It sits right here, right? I would like to figure out how far that is from 0, or the origin. Okay? Is it more than 1 unit? Is it more than 2? Is it more than 3? Is it more than 4? It is more than 4, but it's hard to tell at this point, isn't it? Would you agree that the length of that segment would tell us how far it is from 0? How would we compute that length? Distance formula, which is just a fancy way of saying, say it louder and confident so you know what you're Pythagorean theorem, right? All we're going to do is, would everybody agree that this was our A value right there? Would everybody agree that this would be the B value? And so we will say that this length here is the absolute value of the complex number. So therefore, we have this definition. The absolute value of z is equal to the square root of a squared plus b squared. Is that difficult or easy? It is easy, but modulus. The modulus is the absolute value of a complex number. It's equal to the square root of a squared plus b squared. Given z is equal to a plus bi. So we simply take the real part and square it. We take the imaginary part and square it. And find the sum and square root. So you have an analytical formula. You also have this graphical representation to help you understand. You're just using the Pythagorean theorem. Fair enough? So let's do 2 examples where we find the modulus. Modulus of z sub 1. So the absolute value of the modulus of z sub 1 is equal to the square root of, what is the a value for z sub 1? 2. So I take 2 and I square it. Plus, what is the b value? 4 and I square it. 2 squared is 4 plus the square root of 20, which is 2 roots of 5. That is the modulus. Let's think about really quick what we just did. You said that the absolute value of negative 5 was equal to 5. And right now you also said that the absolute value of 2 plus 4i is equal to 2 roots of 5. So when you think of it in context of that, that's kind of neat, isn't it? I mean, before, if we asked you what the absolute value of a complex number was, you'd be like, I don't know what to do. Now you know. It's the distance from the origin. See if you can do the next one on your own. You're finding the modulus of z sub 2. Square root of 26. Good job. Flip it over. So some of you might be wondering, what is the application? Has anybody taken an engineering course before? 1, 2. Just 2? Physics. 3. Physics. 4. Wow. Not as popular a class as I thought they were. Okay. What are we taking instead? Band. All right. That's Spanish, publications, choir, foods, recess, yearbook. Got it. Nap time. Got it. All right. Well, so trigonometric form of complex numbers. Suppose we have a number here that is the coordinate of a, has a coordinate of ab because it is of the form a plus bi. That would mean that this length is a. This length is b. And this length here we call absolute value of z, right? Or the modulus, which we will also refer to this time as r. You'll see in a second. Okay? Yep, exactly. This would be the radius, okay? And it's going to map to what we've used in trigonometry before, okay? Where is this going? What we would like to do is we need an efficient way of working with complex numbers. If I ask you 2 to the 5th power, what is it? 32. But if I say 2 plus I roots of 2 to the 5th power, that doesn't look so fun, does it? We're gonna make that super easy. Okay? In order to do that, we have to be able to place things into what's referred to as trigonometric form. Sine and cosine are very friendly to us. They have patterns. They are waves. So we'll use that to our advantage. I'm going to insert a theta, and now the trigonometry will map into our complex analysis piece here. So can somebody tell me what is a trigonometric function that relates a and r together? Cosine. In fact, I can make this statement. Cosine of theta is equal to what? Good. Or r cosine of theta is equal to a. Second piece. Sine of theta is equal to b over r, or r sine of theta is equal to b. So if I would like to write a complex number of the form a plus bi, I can simply, instead of using a, I can use r cosine of theta. And we have the plus sign. What do I write instead of b? Yep, r sine of theta. But there's an I on the end. I'm going to place that in front so I don't lose it. Do these have a common factor? I will factor out the r, and I get r times cosine of theta plus I sine of theta. That's trigonometric form, where r is equal to, anybody want to figure out how we come up with r? Look at the picture. How do we determine r if we're given a and b? Very good. So r is the square root of a squared plus b squared. I also need to determine theta. Theta satisfies something. What is a trigonometric function that relates theta, a, and b? We'll do 3 examples, and trust me, you will get this. Okay? Now, let's pause here for a second and understand things that are going to be important for us to write down. You choose how you want to put your notes together for the test. But this looks like something that's pretty important, and I really like the drawing. I think it's pretty. Beauty is in the eye of the beholder, Larissa. I also think that this is very important. Would you agree? That's something I would want to put together in my notes. In fact, wouldn't it be a good idea to have your sheet of notes with you and you start to make them during class? Might want to consider doing that, so then it's not the night before the test you're thinking about putting your notes together, but rather you're accumulating them. So that maybe the night before the test you're coming up with a second draft or something that looks better. This is the only thing I don't want. I don't want examples, folks, okay? You can't write down all the examples that we do. Okay, we are now going to write the trigonometric form of the following numbers. These are complex numbers. The problem is they're very cumbersome to deal with. So we're going to place them into trigonometric form. In order to do so, I need to find 2 things. Because trigonometric form is r times cosine of theta plus I sine of theta. That's trigonometric form. In order to do that, I need to find r, and I need to find theta. So r is equal to the square root of what? A squared plus b squared. What is a squared? 4. What is b squared? 4. Does everybody see that when you come up with b squared, you don't square the I? Don't do that. You would get 0, wouldn't you? Okay? So, square root of 4 plus 4 is square root of 8, which is? Okay, so we've got r. R is 2 roots of 2. Now, hold the horses, but that's something we've done a lot of times before, right? Like, that ain't new. In context with this, it's new. But you know that skill, don't you? So don't be afraid of that. Should, yeah. All right. For the second part, tangent of theta is equal to b divided by a. What is b divided by a? 1. Hey, fortunately, in our last section, we learned how to solve trigonometric equations. So, let's solve that trigonometric equation. Where is tangent positive? Which quadrants? 1 and 3. Is this point in the first quadrant or third quadrant? First. So I don't have to worry about the third at all, do I? So if we inverse tangent of 1, what will we get? 45 degrees. In radians, that is pi over 4. On your calculator, you come up with 45 degrees. You would then translate it into radians because we will be working radians for this portion. In order to do that, you'll multiply by pi, you'll divide by 180, and you realize that that goes in 4 times, so you get pi over 4. So if you didn't see that, that's what you do. So therefore, we have theta is equal to pi over 4. Again, we are working in the first quadrant. Yes, if we would graph 2 plus 2i, we would go over 2, and we would go up 2, right? If it was negative 2 minus 2i, then we would go to the third quadrant instead. Because b over a would still give us 1, right? So this would be the third quadrant, or 5 pi over 4. This would be the first quadrant, which is just pi over 4. So now I have my theta, I have my r. Let's write the trigonometric form. So 2 plus 2i is the same thing as, what is r? 2 roots of 2 times parentheses cosine of pi over 4 plus I times sine of pi over 4. So this is my form right here, r cosine of theta plus I sine of theta. For r, I put in my 2 roots of 2. For theta, I put in my pi over 4. Yes. And it looks like the bell's going to go. That's where we'll pick up tomorrow. Here's your assignment to get started on. This will just be graphing, okay? And I think finding the modulus, okay? Very straightforward. Tomorrow, we will have a full day of instruction. And after we have that full day of instruction, we will then move on to a nice assignment. You have a work day on Friday. Work day on Friday. Yes. These are the same things. And I'll show you why tomorrow. I'll show you why right now. Do you know what the cosine of pi over 4 is, or the cosine of 45 degrees? It's the root of 2 over 2. And the sine of pi over 4 is also the root of 2 over 2. If you were to multiply this through, 2 over 2 will cancel, won't it? And root of 2 times root of 2 gives you 2. Same thing over here. You'll end up with 2 plus 2i. If you were to distribute this through, you would come up with that in the beginning. The deal is, this is cumbersome to deal with. This guy right here. Yep, I'm saying this is what we want. This is the trigonometric representation.